Have you ever tried to use a flashlight to point at something? If you have, you may remember that it doesn't work very well. The beam is wide and gets dimmer the further you are from your target. But using a laser, on the other hand, results in a sharp, focused point of light. What is different about the light created by a laser and light created by a flashlight? To discuss these differences, we first have to understand the dual nature of light. Light, weird as it sounds, is both a wave and a particle. The wavelength of light, or the distance between successive peaks, determines its color, or even whether it is visible to us at all. Visible light has wavelengths from 390 nanometers purple to 750 nanometers red, or 1/10 times the width of a human hair. However, light is also quantized in massless particles called photons. The energy of a photon is proportional to its frequency, which is the speed of light divided by its wavelength. What are some characteristics of laser light? Laser light is monochromatic, has one wavelength only, what we perceive as one color, coherent, photons move together in an organized fashion equivalent to wavefronts starting together, and directional. There's a tight, concentrated beam of light with minimal dispersion. LASER is actually an acronym. It stands for Light Amplification by Stimulated Emission of Radiation. Radiation just means light emitted by atoms, which I'll explain in a second, but what is stimulated emission? Let's look at the structure of atoms and see. A single atom consists of a nucleus filled with protons and neutrons surrounded by electrons. At first glance, these electrons exist in a cloud, but actually there is a lot of order to this complex system. The electrons have to stay on specific energy levels, where being on a specific energy level corresponds to the electron having a different amount of energy. For example, take an atom with two energy levels, call them 1 and 2, and an electron in energy level 1. Call delta E the amount of energy separating the two levels. When a photon with energy equal to delta E hits the atom, the electron can jump to the second energy level, becoming what scientists actually call excited. Correspondingly, an electron can jump down from level 2 to level 1 by emitting a photon with delta E amount of energy. If this photon then hits an identical atom with an electron at energy level 2, it will continue on and also stimulate emission of an identical photon from that atom. This can continue on in a chain reaction if there are a bunch of identical atoms present, creating many photons very quickly, which all have the same wavelength and therefore color, therefore they're monochromatic, and phase and direction, therefore they are coherent and directional. This works for multi-energy level jumps and many different types of atoms as well. A laser consists of a medium of identical atoms surrounded by a flash tube inside a casing. The atoms have a difference in energy levels tuned to the light emitted by the flash tube so that when the flash tube is turned on, it can stimulate emission, creating the amplification chain reaction necessary for laser light. There is a mirror at each end of the laser body, allowing the photons to be reflected back and forth to hit other electrons and stimulate more emission. The mirror at the end is half silvered so that some of the photons can travel through it, leaving with the same phase and direction and creating the characteristic laser light. So, to summarize, we have learned that 1. Light comes in both photons and waves, 2. That photons can be emitted from atoms by electrons jumping from one energy level to a lower one, and 3. That a chain reaction can stem from this type of stimulated emission in a uniform material and used to create laser light.